Okay, I went upstairs. It's usually a matter of trade-offs. Okay, does this sound a little better?
I can't hear properly. I'm not sure if it's me.
I can, for once, I can actually understand what you're saying.
Yeah, like just a couple of words only.
Yeah, it's usually better upstairs.
Yeah, it sounds good as of right now.
Sounds
Okay,
fine.
I'm going to try one other change. Hold on, if I can get to.
Oh no, please.
Okay, does this sound better?
For now.
Yep.
Yeah, okay. All right, I'll have to confirm you can still hear me so I don't talk for an hour to myself. Okay, so the question was, I'm on a committee that's looking at curriculum for CS 210 and 211. And I'm curious, I'd love feedback. You don't need to say it out loud right now. If you don't want to, you can email me. But one thing they're trying to get a handle on is people that enroll in CS 210 that do not continue into CS 211. And it turns out many people that do go on to CS 211 do not take it the very next quarter. They take time off or wait a quarter or two and so forth. They're trying to get a handle on kind of why and just more details around that. So if anyone would like to share thoughts, that's cool. Otherwise, you can just email me.
Well, just a statistic for me, but I'm not going to be taking CS 211 because I'm transferring to another school. And for that matter, CS 210 doesn't transfer over.
Okay.
So that's one of the reasons why I'm not transferring over. I only joined because I heard that you were a good professor.
Well, that's nice to hear. They're also looking at, there's some business computer science classes, and then there's computer science for engineering, and there's kind of different groups of students. You know, some people take it as an elective, others are trying to get into University of Washington and so forth. So there's kind of different groups and motives for taking it too.
Yeah, so for me, I'm supposed to be taking it next quarter, CS 211, because I have to get it done for my AAS. But I would have skipped it if it weren't for that fact, because next quarter I'm gonna be taking harder classes, and I know CS 211 from my friends I've talked to, it's a more challenging class, and sometimes I don't think I would be able to handle the workload with Calc 2 and another class. So.
Okay, just one piece of advice I would share is, honestly, these types of classes could be structured so that everyone gets an A, or they could be structured so that everyone flunks. There are Java classes out there at certain colleges that I would probably flunk the class. So don't get, you may from time to time run up against like really impossible instructors. Don't get totally discouraged. Also, a lot of people want to go to the University of Washington for obvious reasons, but oftentimes I think it's because it's kind of like the only university that they're even aware of. So I highly encourage you, if you flunk a class in the future, if you apply to the UW and don't get in, whatever, I encourage you, don't give up. There's a lot of other options out there. And I highly recommend the smaller colleges too. And on top of that, even the private universities are not as expensive as you think. What I'm finding more and more, and historically they always kind of did this to begin with, but I think they're doing it more often. They jack up tuition, so tuition is astronomically expensive. But then most people end up getting a scholarship that might amount to half price off. So what they're doing by doing that is, if you're more affluent, wealthy, whatever you want to call it, you're going to pay full price. And if you're not, they want to, these colleges want to get as much money out of you as possible without you declining them and going somewhere else. So they want to kind of offer discounts for people that need the discount, but they don't, if they offer a discount to somebody that doesn't need it, they're losing money, right? So a lot of the private universities will offer programs and scholarships, whether they're called need or merit-based. Oftentimes it's like half off. So, okay, that's my little soapbox on that.
Yeah, just another thing. What I've noticed, same thing, like a lot of my friends as well, is that there has only been like 2 teachers that I've seen for CS211 for like the past couple quarters. I don't know if years maybe, but the reviews for both of them like aren't the greatest. I mean, yeah, I've even recommendations from friends. Like some people would say, you know, stay away from this guy or that person, but there's only one other person, and it doesn't seem that they're any better. So I think having only 2 professors that aren't the greatest probably turns people off as well.
Yeah, as you get up to that level, the instructors have to have more knowledge and experience. And I have heard a couple horror stories where I think there was a student that had maybe it was a learning disability or some kind of challenge, and the instructor was just not helpful. Like he basically said, you know, if you can't do it, tough luck for you, kind of thing. But yeah, there's just know that there's always like a talk. There are always other options out there too. So, okay, this week we're talking about Chapter 9, Inheritance. And then next week I haven't totally mapped out the schedule for next week yet, but for Tuesday, we'll talk about software development lifecycle. This is a little off topic in terms of the final, but it'll be a light week for work. So you can catch up on homework. And we'll do an exercise in class that's worth points next week. So if you attend, you'll get the points, and then by the end of class, you're done with it. So it's not like you go away with more homework. And then the following week after that, so this is the extra credit assignment. So please let me know if you plan to do this. And the assignment is you'd write a video game. And it can be pretty simple, and then do a short presentation to the class, anywhere from 2 minutes to 5 minutes. And then I can also do an optional review session for the final exam. And then the final exam is the week of March 23rd. Okay. So I'm going to start off with lecture notes, and then I'll go through some example code here. Oh yeah, just shoot me an email if you're going to do the extra credit. Okay, can you see the PowerPoint?
Yep.
Okay. So some of this gets kind of philosophical, and a lot of this has to do with design. So when we get into object-oriented development, there's a lot of different ways to code it that it will still work. It's just not the best design. So what they're talking about here is with application development, it's an expensive, time-consuming process. The labor expense of the application developers is one of the largest expenses. And before object-oriented programming, if you wanted to develop something that was 80% similar as existing code, you'd probably have to write like a new function. And oftentimes you would have to retest much, if not all of the code, because you've kind of like opened the hood and got in the engine and messed with stuff. So a lot of the motivation for object-oriented development has been to make application development more like Legos, where it's plug and play and you're just assembling the Lego bricks together without having to touch or interrupt the existing code. Now, it doesn't always play out like that, because I've seen a lot of IT shops use object-oriented languages like Java or C++, but they continue to write procedural type code. So again, this is a a design principle kind of above and beyond the syntax of the language. Okay, so here is, hold on one second. Let me show you a diagram. Okay. We have what we call class diagrams, or UML, for Unified Modeling Language diagrams. And it's essentially an illustration of the different classes in the program and how they relate to each other. And with inheritance, what we're doing is there'll be a superclass, and we extend the superclass into more specific types of classes. So let me show you a couple examples here. Okay, here's a UML class diagram for a hospital and the people in a hospital. And there's a lot of specific notational rules. We're not necessarily going to go into all those details. So things like these arrows, whether or not the arrow is colored in and so forth, has to do with the relationship between the classes, and is it a one-to-one relationship or one-to-many or many-to-one and so forth. So for instance, an airplane has one pilot. So one airplane, one pilot, one-to-one. But an airplane has many passengers, so that's one-to-many. And there's many passengers on the plane, but any one passenger can only be on one plane at a time. So they have specific notational rules to illustrate that. What I'm going to focus on today is simply the structure of which classes extend which classes and where we would place the data fields and the methods. So in a hospital, they have one class for the hospital itself. And the data fields would be the name, like Evergreen Hospital, the address, and the phone number to the hospital. Okay, and then we would have a superclass for people. And any data fields or methods specific to people would be in that class. So title, first name, last name, birth date, gender, home address, phone, etc. So notice if we create an object of this person class, they might work at Evergreen Hospital, but any data attributes for Evergreen Hospital are going to be in the hospital class, not the person class, because the name Evergreen Hospital applies to the hospital. It doesn't apply to the person. Okay, any questions about that before I go on? Okay, you can still hear me, right?
Yeah.
Okay. So now we can extend the person class using inheritance. So we can extend the person class into patient, the patients at the hospital, and then staff who work at the hospital. So patient could be a class, and staff could be a class. So data fields in the patient class would be well, I actually kind of disagree with how they design this. But a data field for the patient class might be the date they were admitted to the hospital, or name of their health insurance. Or can you think of any other data fields specific to a hospital patient that would go in the patient class? Oh, thanks. You can still hear me, right?
Yeah, maybe like pre-existing conditions or something.
Yeah, exactly. Good example. So, so that's a good example. Now, however, the extended classes will inherit all of the data fields and methods from the superclass that they're extending. So you do not need to put name in the patient class because it will inherit name from the person class. So this actually kind of looks wrong to me. I'm not sure why they did that. Same thing with, oh, I see what they're, okay, my fault. I think this notation here is indicating that it's an inherited field. I just normally wouldn't even write it on the extended class. So name, gender, birth date are inherited from the superclass. So the additional fields you would put in the patient class are the new fields that apply to patient that do not apply to just a person class. And then same thing with staff. So staff could have, hire date, salary, education, certification, so forth, all the data fields that would apply to employees that don't necessarily apply to a patient or just a generic person. But the key here is fields that are in a patient class and an employee class should go in the superclass up at top because that way they get extended and inherited into all of the derived classes. And you can keep going with this. So if we go over to staff, there's different types of staff. Operations staff, administrative staff, technical staff. Among operations, there's doctor or nurse. And then within doctor, there's a specific type of doctor, surgeon. But what makes this object-oriented is that as we extend these classes, they inherit fields from the classes they extend. And you can see how each extended class gets more and more specific. And the key here too is that we can quickly add on additional classes by extending the class. And you would not need to change anything in the existing classes. You don't need to redevelop them. You don't need to retest them. They could be completely locked down and we can still extend those classes. Okay, and hold on 1 second. I'm gonna get a glass of water because my voice gets all dry from all the talking. So 1 second. Okay, any questions so far before I go on? Okay, so they don't necessarily seem to like this type of question on the final exam, but sometimes I'll write questions where I might say, write a UML class diagram for the Seattle Seahawks employees. And then you'd write it out, player, staff, coaches, and then you could extend, coaches could be extended into offensive coach, defensive coach, special teams coach, blah, 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 just like this. It would just be a different example than a hospital. Okay, so that's what they're talking about here, but this is kind of I didn't like that example. There's kind of smaller. Okay, in terms of class relationships, so there's is a relationship. So a surgeon is a doctor, or an administrative staff is an employee, right? It's like a type of class that it's extending, a more specific type. Then there's like has a relationship, which is a boat has a motor, or a plane has a pilot, or a class has a teacher, or a house has a fireplace, that sort of thing. Okay, so here, this would be an example without using inheritance. So they create an employee class, and don't worry, we're going to go into Eclipse a little later on here. So here they create an employee class, and they have public int get hours, return 40, get salary, return 40,000, get vacation days, return 10, get vacation form, return yellow. So there's your employee class. And then they create public class secretary, and it looks like all of these are the same. So it's redundant. These slides kind of, see, I need to customize these slides. They kind of skip around a lot. But this would be a good example where really what should be done is you would create the secretary class by extending the employee class. And we'll look at examples in Eclipse like that. Oh, here we go. So this is the syntax. So public class secretary extends employee. And secretary, I think, is an outdated word. It's usually called admin assistant now, I think. But public class secretary extends employee. So extends is the keyword here to use inheritance. This is the class we're extending, employee. And then this is the name of the new class that we're creating. Okay, and so here, if we go back to that secretary class, where was it? So all of these fields were completely redundant with the employee class, but they did create one new field. Like it's like a method to take notes. So they wanted to create a secretary class. It's almost completely identical to the employee class, but they needed one more method to take notes. So through inheritance, it can be a lot more simple. So here you would have public class secretary extends employee, and then you simply add the additional method that you want to create in the new class. And all of the classes that were listed in the superclass employee are automatically accessible or created in the new class. So we don't need to recreate these classes. We're just kind of adding on to them. So any questions about that? All right, you can still hear me, right?
Yeah.
Okay. Okay, so now we're going to create another class called lawyer, and it's also going to extend the employee class. However, for the lawyers, their vacation form is pink, not yellow. So what we're going to do is we're going to override the get vacation form from the employee class. So if we go back to that employee class, here's the method get vacation form. So public string get vacation form return yellow. And here's the method declaration, public string get vacation form. So now we go back to the lawyer class. So public class lawyer extends employee. And then they create a method with the exact same name and parameters. In this case, there's no parameters. So public string get vacation form. But this one returns pink, not yellow. So what ends up happening is the lawyer class automatically gets all the methods and data fields that the employee class has, but when we call get vacation form, if the object is a lawyer object, it calls this method and it returns pink. If the object is an employee object, it calls the employee method and it returns yellow. And later on in the stack, there's a principle called polymorphism. That is something that might be on the final exam. And that is polymorphism. Polymorphism is the ability of the program to kind of encapsulate the type of object that the class is. And as long as all the object types are derived and extended from the same superclass, it doesn't care what kind of object it is. It will just kind of blindly call the appropriate method. So if it's a lawyer object, it calls this get vacation form, which returns pink. If it's an employee object, it calls the other get vacation form method, and that one returns yellow. So in this way, you can extend a class and create unique behavior for the methods depending on what kind of class you have. Another example might be like, think of like a video game, like the old school video games with the different levels. So you might have like a battleship submarine game, let's say with 10 levels. And at the first level, the battleship might have a real lame gun. But when you're at level 10, it could be torpedoes. So when you might have a method called something like fire or launch to fire the gun. Depending on which level you're at in the game, if you're at level 1, it fires the lame gun. If you're at level 10, it will launch a torpedo. And the code won't really care what level you're at. It will automatically know which method to use. And this also makes it easier to program in an object-oriented way because you don't really need to know what level you're at in a video game or whether the employee that you're looking at is a lawyer or the admin assistant. It just will automatically use the applicable corresponding method. And those methods will have different behaviors based on the type of object that it is. So here, it looks like the lawyers also get more vacation, which is actually probably false. They probably end up using less vacation even if they have it. I have lawyer friends that make good money, but they work so many hours. It's like, yeah, well, if a computer science programmer had 3 jobs, they would make more. So if you ever look at law school, come talk to me first. I have opinions on it. Okay. Okay. So we've kind of talked about most of this. Okay, so now here we overrode, we have public class legal secretary extends secretary. And legal secretary has its own get salary method. It overrode the get salary method in the secretary class. But what if we actually want to call the get salary method in the original class rather than its own get salary method? You can use the keyword super. So super dot and then method name will refer to the superclass that we've extended. I don't necessarily see that used a lot, especially at this level of programming, but just kind of know that that's an option.
Is that like pseudocode?
Well, I mean, this could be actual code here, but this is just a small fragment. This is pseudocode up here, the super dot method. But here, they have double base salary equals super dot get salary. So what they're doing here is saying a legal secretary is going to make whatever the secretary makes plus an extra 5,000.
Right. Okay.
And we'll look at the examples in Eclipse might be a little more useful too. So we'll look at both. Okay. Okay, so remember what constructors are. So constructors are methods that have the same name as the class. And the constructor methods get called automatically when we create an object of the class. So here, public class employee, it's got a data field for a number of years, probably a number of years with the company. And then here, public employee int initial years, and it sets the years they've been with the company. If you extend this class, the subclasses do not inherit the original class constructor. They get their own constructor, but it's a default constructor. So subclasses receive a default constructor that contains, so here's public lawyer, and it has a call super to the base class constructor. Some of this is kind of academic details. But the constructor method, though, you can overwrite it also. So when we extend, like if we extend the employee class to create a lawyer class, we can write our own constructor method in the lawyer class. Okay. Sorry, I'm deciding how much detail to go into here. Oh, okay. Now, we'll have to compare objects from time to time. So we might have an array of people objects, like a sports team roster. And we might have to say, we're looking at one class object for Matthew, and his jersey number is number 6 on the baseball team. And we might be looping through an array list of baseball player people objects in the roster. We might be checking to see, does each element equal our class object we have for the player Matthew? You can't just say, like, does object 1 equals object 2 using the double equal sign equality operator, because that's actually comparing the reference in memory to the objects. So you can't just say, like, does this object equal that object? It's more effective to compare specific data fields of the class objects. So if our people objects in the baseball roster are player 1, player 2, player 3, player 4, you don't just say, does this player equal player 4? You would compare the specific data fields, like my player dot name, does that equal player 4 dot name? So you're doing the data checks on the specific fields within a class object, not just necessarily comparing the entire object as a whole. Let's see here. I'm going to go into the code pretty soon. So this is saying we can cast object parameters to a specific type of class object. I already talked about polymorphism, so we're good there. Okay, let me go to Eclipse now. All right, you can still hear me too, right?
Yes.
Okay. Okay, so this program simulates a bank. So to start off here, we may have already, sometimes I have an assignment on this, but not this quarter. I may have already shown you a simple bank example, but to start off here, we have the bank class. And this is basically the class with the main method and a menu that's kind of like a ATM menu. So basic functions like deposit, withdraw, create account, so forth. And then there's an account method. So some things in here we're not going to worry about because, like, for instance, it has array lists, and that's not really covered until CS211. So that's not the part of the program I'm going to focus on. So don't really worry about it too much for now. But this is a public class account. So it's got some fields, ID, owner name, account ID, balance starts off at 0. And then it's got the basic methods. So withdraw funds, deposit funds, set balance, set owner, get balance, get ID. Okay, this is similar. I know we looked at a similar program to this. May have been the cafeteria meal card program, maybe. I can't remember. But this is just a generic basic account. Then we can extend the basic account into two types of accounts, checking accounts and savings accounts. So here, public class checking account extends account. And then they're adding on data fields that only apply to checking accounts. So public static, final int, there's a constant here, fee bearing checks. Here's public static, final, double, fee, 50 cents. Those are constant variables to indicate fees. And here's the constructor. So public checking account, and they bring in owner name, starting balance, owner name. It's matching the owner name and starting balance with the same fields from the superclass, from the account class. And then here's the withdraw method, but they're overwriting the withdraw method from the account class. And it looks like for the most part, they're adding on the fees. Okay, then there's a savings account class. So again, so public class savings account extends account. They create some different fees here. Free withdrawals equals 3. Another fee here for $1. Here's the constructor. And now here is another withdrawal method. So they're overriding the withdraw method. And it looks like primarily the main difference here is there's different fees. So different behavior there. And then, so back in our main, then there's a transaction class here. Somewhat generic. Okay. And then here's the bank class with the main methods. I'll just run this so you can see what this says. Okay. Okay, so here's our menu. This is inside, I believe, a while loop, was it? Yeah, here's the while loop. So, okay, create account, I'll hit 3, create account, checking your savings. It doesn't tell me what kind of input it's looking for here. I guess I'll just type checking and see if it works. Okay, I'll create one more. So create account, savings. Okay, and then view all accounts 5. So view all accounts, I just went through the array list and printed a list. So here are the 2 accounts, account 0, account 1 with the name and balance. But the main point I want to get across here is how, so they have, for the accounts, they have 3 accounts classes, account.java, checking account.java, savings account.java. And remember the data fields and the methods in the account class get inherited by the other types of accounts, checking account and savings account. But the new classes can override the methods to make their own versions of those same methods. Okay, any questions on any of that before I go on? Okay, and you can start hearing me, right?
Yep.
Yeah.
Okay. Okay, one more example here. This is an address book, or a newer example would be, your contact list on an iPhone. So here is test addressbook.java. This basically has the main method and the code to run the program. And then just like the accounts, we have the superclass here, person. And this was kind of like the person or employee class back in the hospital example. So we have data fields, private string name, private int age, private char gender. Here's the default constructor, just kind of sets all the data fields to initial values. Here's another constructor when we actually are receiving all the data fields passed in. And then get and set methods for each data field. So get age, get gender, and then get name, set age, set gender, set name, and phone number. So that's the superclass person. Okay, then there's different types of contacts in the contact list. So there's personal friend. So class personal friend extends person. They have a list here of common interests. Here's another. Now remember, this is overloading the constructor. So overloading is when we have multiple versions of the same method, and the different versions have different parameters based on what data is passed in. Overriding is when we extend the class and we create a new version of the method in the extended classes. So these are 2 constructors that they're overloaded. Okay, and then we have add common interest, because these are methods specific to the personal friend class, and get common interests. Okay, then we have business associate, like a talk, extends person. Again, here's the constructor, another constructor with all the data fields as parameters. And now we have set title, get title, because the personal friend didn't have a title field. And set employer, get employer. And then we have, is that it? Yeah. So the superclass was person, and then we extended that into either personal contact or business contact. So let me run this really quickly here. Oh, this really doesn't do much. There's not a lot of transactions in the main method here. But so here again, though, here's the superclass person. We extend it into business associate, personal friend. We could very easily create a new additional types of classes. So here where it's class, personal friend, extends person, we could have another type of a class. So it might be recruiter. Well, so recruiter, this is a good example actually. For if I was going to create a recruiter class to keep track of recruiters that call me, I would not want to extend the person class and create recruiter. I would want to extend the business associate class and create recruiter, because a recruiter would be a subtype of a business contact. But maybe we would create like family member, and from family member that would extend the person class. So you can see how this gets kind of philosophical, because this would work 101 different ways, but you want to design it in the way that makes the most sense. And if I had a recruiter class and I had a data field like recruiting specialty, and that would contain a value like project management or application development or systems analysis, I would not want to put that data field in the person class, because then it would show up in all of the classes. And a personal friend is not going to have a recruiting specialty, or should not have it. Okay, so any questions about that before I go on? Okay, I might have to grab my power cord here in a few minutes. Okay, so let me show you another example. So similar program here. So I'm looking for the main method. Oh, was this? Hold on, 13.7. Great. Oh, this is wrong. This is not the program I want to look at. Here we go. Okay, so this program computes grades for students. So actually, I'll just run this so you can get a look at this. This loads up a data file, and hopefully I can remember where the data file is located. Okay, so it's got in the output here, it's got a list of names, has some test scores, and it says pass or did not pass. But I think how it's determining pass versus no pass is based on the type of student it is. So now let's go look at the code to see how this is running here. Okay, so here's our superclass student. So abstract class student, I'm going to come back to the abstract keyword in a minute. So they have data fields, a constant for number of tests, 3, protected string name, protected test, which is an array of ints, and course grade, which is a string. The protected keyword is an access modifier, just like public or private. What protected does is it says these fields can only be accessed by this class or any extended classes of this class. So it's in between private and public. So now there's different types of students. So there's undergraduate student. So class, undergraduate student, extend student. Here's the constructor. Now we have a method compute course grades. And it's doing blah, 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 but really just take notice of this. So it has if total, if basically if the score is greater than or equal to 70, they pass. Otherwise they don't pass. In graduate student.java, so class, graduate student, extends student, they also override the compute course grade method. But now, if you're a graduate student, they only pass if the score is 80 or above. Now, let me go back to the student class here. One way to do this, we could program the same program without using the different classes, graduate student or undergraduate student. We could just make everybody a student, and we could have a data field in here saying, you know, type, and that could be set to either undergraduate or graduate. It could even be like a Boolean value. And then we could use if, then, else clauses in the compute grade method and say, you know, if undergraduate student do this, if graduate student do that. So that would work. That would be totally fine. But creating the different types of classes for the different types of students kind of makes it more object oriented, because you never know, you might need to create new classes in the future. And if we had all the code inside the student class, every time something changed regarding students, we would have to open up this code, change the code, update it, and then test it all over again. But if our college doesn't have any athletics, and then next year they decide, oh, now we're going to D1 athletics, now suddenly we would need new types of students, like student athlete or something. And using the object-oriented model, we could create a new class, student athlete, and we could add on whatever methods we need, and maybe they even calculate grades differently, who knows. But the key is these existing classes would not need to change, and they would not need to be retested, which is theoretically a huge strategic benefit to application development. But like I said at the beginning of class, a lot of development shops, they're using object-oriented languages, but they don't always do object-oriented design. So there may be a really important project, they're up against a deadline, and the developer knows, oh, the right way to do this would be create a new class called student athlete, but I don't really have time for that because my boss is yelling at me to get this code done today. So I'm just going to go into the student class and create like a new field, you know, string athlete equals, or Boolean athlete equals true or false, and put a hack in here in the student class. And that's what happens a lot. So typically the development shops will create like coding standards that they have to adhere to. They'll have code reviews where the senior programmers will review the work of the junior programmers and review the code for stuff like that and say, you know, no, you shouldn't have a athlete yes or no data field in your student class. That should be a new student athlete class, and you should create that by extending the student class. So a lot of this stuff has to do with the design of the program. Whereas at the beginning of the quarter, it was more about the syntax and just getting the code to run sort of thing. Okay, any questions about this? Okay, I'm going to take a 1 minute. I muted myself too early. I'm going to grab a power cord. I'll be back in 1 minute. Okay, any questions so far before I go into the next example? Okay, you can still hear me too, right?
Yeah.
Okay. I was playing soccer with my kids recently, and I was out of breath, and I was like, "Oh my god, I have COVID. I have shortness of breath." And then someone was like, "No, you're just old and out of shape." Okay. Okay. I'm gonna run. So this is a pet store code, and there's an assignment on this. So pay close attention. Let me just run this first to show you what this does. It's nothing too exciting. Okay, enter C for cat, D or dog. I'm gonna enter C for cat. Enter the name of the cat. This is a true story. I had a cat whose name was Socks, who was named after Clinton's cat, Bill Clinton, like black and white cat. Okay, color black. Okay, now D for dog. Oliver, 100. This has kind of a quirky bug in it too, I think. So now I enter C for cat, and now it says enter the name of the cat or stop to quit. Well, it should have asked me, should have prompted me to give the stop option earlier, but this one. Do stop. Okay. So it says Socks is a black cat, meow, meow. Oliver is a dog that's a typo, that weighs 100 pounds, bark, bark, bark. So now let's look at this code here. So petstore.java, it has an array list. You'll talk more about that in CS211, but that's it's like an array to hold the list of pets. And this essentially has the main method and it has the while loop, kind of like the bank program to produce that menu for creating the objects. Okay, so then here's the superclass pet. So class pet. Oh, and I forgot to go back to the abstract keyword, but I'll mention that in a minute. Class pet. So private string name for the name of the pet, right? Because any pet you have, regardless of what type of animal it is going to have a name. And then get name, set name, and it has a method, speak, public string speak, what time is dinner? We had a dog for a year, and I'm not kidding. If I did not feed him by 6 p.m. sharp, he would jump up in the house and rip the Wi-Fi cable off the house, and there'd be we would have no internet. And it was like he knew exactly what he was doing too. It was really weird. All right, so that's the superclass. Okay, any questions about this class so far? Yeah, my wife wanted a small dog, and she wanted like a beagle. My daughter wanted like a Fufu Paris Hilton type Pomeranian, the kind that like women put in their purses. And I wanted a Newfoundland, which are like these big, huge, hairy, look like a black bear, woolly mammoth. My 11-year-old son picked out a coon hound, which is basically like a hunting dog to hunt raccoons. And it was a sweet dog, but all he wanted to do was escape. If any opportunity he had, he would run away, and he could run like a greyhound. And then we'd get a call 10 minutes later, and he'd be like down by Lake Sammamish, 6 miles away. So I re-gifted him to a family in Eastern Washington, and he now lives on a ranch. So if we ever get a dog again, it'll be a small one. All right, so let's look at the dog.java. Okay, so class dog extends pet. So now we add the field weight. So arguably weight probably should have been in the pet class, but for whatever reason, we didn't care about weight for cats, but we care about it for dogs. I guess that could be a factor. Cats all more or less weigh somewhat the same generally, whereas dogs could be so heavy you might not be able to lift them, or they could be small. So then we have public void set weight, public double get weight, and then here's that method speak. So public string speak return bark bark bark. So does not take any parameters, but it returns a string, and here's the return statement. Okay, and then here's the cat class. So class cat extends pet. In the cat class, apparently we don't care about weight, but we care about the color of its fur. So coat color. And then we have get and set methods. And then we're overwriting the speak method. And now we're saying meow, 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 because it's a cat. Okay. And what I forgot to mention before, the abstract keyword is for the superclasses. The keyword is abstract. And what it basically means is, where did we see that? We saw that in might have been the bank program with the account class, or I think it was the contact list program. If you make the superclass abstract, it means you cannot have any objects of that class. And this might be a good example, because with an abstract base class, you're basically saying there's not enough information here to actually have an object of this class. We're only creating this as like a foundation for you to extend and create more specific classes. So, if you drop off an animal at the Humane Society or pick one up, you can't just go in and say, I'd like a pet. You have to tell them, I'd like a dog or I'd like a cat. So maybe in that instance, the pet class would be abstract, meaning we're not going to let you create an object of just type pet. You have to specify whether it's a dog or a cat. Okay, so on Canvas, that code that I just walked through is posted right here. Pet class example, petstore.java, pet cat dog. And then for assignments, and this really should not take very much time. Like it's practically a copy and paste exercise. But here, if you go into program assignment 8 pet class, modify the program to include 2 additional classes for 2 additional types of pet animals by extending the pet class. Ensure the speak methods are unique by overriding the speak method in the pet class. So basically, I'm just saying, create 2 new types of pets and give them different, mostly override the speak method, but you could give them other data fields and methods too, if you like. So any questions about that? So when you do that, so here's class dog extends pet. What's another type of pet? Rabbit. You could have class rabbit extends pet, and just update. Then you just update the methods, override them, and in your main method, you could just update the menu to call a rabbit object. I'm not so concerned with the update in the main method, though. It's mostly about creating the extend the class to create an additional type of pet class.
So when we do this, do we just submit the pet class, or do we submit the whole method and everything?
Just submit everything so it still runs together.
Okay, so in my previous one that I was trying to submit, it only gives an option to submit one. So I made a zip file and I uploaded it. Would that be okay?
Yeah, well, I'll correct that. That's a setting, and so I'll make it accept more than one file.
But in my sports team roster, I just submitted it as a zip folder.
That's fine. If I can't open it or something, I'll look at it.
Okay.
Yeah, it should accept multiple files, but I'll check that.
Yeah, it only gives one option.
Okay, I'll see if I can change that.
Thank you.
Okay. So that's all I have for today. So on Tuesday, we'll do that in-class exercise. And so if you attend and do the exercise, you'll get the points. So it shouldn't be a lot of work. And then the following week after that, we'll have the presentations, and I can do a review session if you like about regarding the final exam. Okay, and if anyone has any questions, I can stay on too for a few minutes.
Really quick question. We never really had a midterm, right? I just want to make sure that I didn't miss something because I was just not paying attention.
Yeah, no, I did that on purpose. I go back and forth on if we should have a midterm
okay.
or not.
I just wanted to make sure. Thank you.
Yeah.
So can we go?
Yep, that's all for today. So have a good week and a good weekend too.
Thank you.
I have a quick question.
Yeah.
So for the exceptions, just like once you write like exception E in a catch block, what does it exactly do? Like if I'm like running, sorry, yeah, I gave really vague. So say I'm like looking for a file, I'm like trying it, and then like I have a try catch statement. So obviously exception, I believe you said was like a class, and E looks for the right exception to throw, or
yeah. Let me see if I can find where the example was for that. Oh, here we go. 8.2 or 8.6. Let me see if this helps. 8.2. Okay, so like this one. So enter a number, try.
I can't see your screen.
Oh. Here. Okay.
All right.
So prompts to enter a number. There's a try block.
Yeah, so something like that. Yeah, like input mismatch exception. Is that like a kind of like a class? Or no, actually the exception E, the one that's not specific. So it's exception.
Oh yeah.
All right.
So the exception class is a special class built into the language, kind of like a string class.
Mhm.
That's basically it's types of exceptions or types of errors. So this catch block will catch any type of exception. It's just like any error, catch it here.
Yep.
This is to catch specifically input mismatch exceptions. So if we comment out this catch block, then this catch block will catch it.
And it's gonna return like the one specifically to the problem that we're having. So like if we don't have a file, then it's gonna catch that and it's gonna like return, oh, files doesn't exist or something.
Well, it gives you like another opportunity to recover without crashing. So like let's run this guy. Okay, so enter number and I enter H, enter. Okay, invalid entry. So this caught it, and then it said invalid entry, but the program continued on and completed successfully. So it catches it and prevents the program from crashing.
Yeah.
And now we could code this to say, here it just says invalid entry and then it continues on and finishes. But we would have an opportunity to prompt the user again to enter it.
Yep.
So like give them a second chance.
If we comment that out, that first catch block, and we run it, can you just do that real quick so I could?
Yeah, then this one here should catch it because this catches only this type of exception, whereas this catches all of them. So if we go this. Okay, and I think when we ran this last time, this error message one didn't actually work, but let me just print something out so we know we can prove that we're actually in here. Okay, so we should run into that print statement now. Okay, so G. Okay, catch block is here. So now it fell down to this catch block.
That makes sense.
For some reason, the error message is null. I'm not sure why that's working. Maybe we need to include a special library or something.
Yep. Okay, that makes sense. Thank you.
Yep. Okay, any other questions? Okay, have a good weekend and a good week.
Thank you.
Thank you.